It's strange to think that why can't organisms simply recycle their energy over and over again? It turns out that during every energy transfer, some energy becomes unavailable to do work. In most energy transformation, more usable forms of energy are at least partially converted to heat, which is the energy associated with the random motion of atoms or molecules. Let's take an example to explain the concept of entropy more. If we suppose that when heat engine takes heat and turns it to energy, the molecules in the system are all regular and behave in an ordinary manner. The efficiency will be 100% if every process in the engine would be completely reversible, meaning both system and surrounding could return to their original state. This is known as Carnot's principle. But that doesn't actually happen in the real life, as some molecules behave randomly. There must be an irregularity in the system and randomness in the movement of molecules. And this randomness is what causes energy loss. Energy will not be completely converted into work. The second law of thermodynamics states that no cyclic process can convert some quantity of heat entirely into work. Some of the heat will always be lost to the surrounding. The randomness and the amount of energy loss in the system defined as entropy. We can state that every time we choose to look at the second law of thermodynamics, it will inevitably result in the discussion of entropy. Entropy is a state of function measured in joule per Kelvin. We can represent it by using letter S. We can get the equation or the change of entropy by dividing heat over temperature in Kelvin. We can say that any reversible process, the change in entropy will be equal to zero. Now we will expand on the concept of entropy as applied in the thermodynamic system. As shown, we will define the most two important concepts related to entropy. The first one is microstate, the second one is macrostate. Microstate is a specific configuration of all the particles and energies in the system. Entropy can be rationalized if we examine the concept of microstate which introduced by Boltzmann. If we need to know more about the concept of microstate, there is an example. If we have two tanks, in the first tank, which is insulated and contains air which depressed with impermeable membrane as shown in the figure 1. If the air there has a specific pressure and temperature as similar as the second tank, which the air is separated in all parts of the tank. If we put piston in the first tank, we can get work from it. Comparing with another one, it will not accelerating any work. We can conclude that if entropy increase, the level of energy decrease, the accelerated work that we can get from it is so small.